Hey, so every day, hundreds or possibly even thousands of scientific papers get released online, either on archive or other kinds of online sources. And consuming all of this is definitely a challenge. But what if AI can help here and AI can help us in consuming these technical papers in a nice way? So today we're going to look into something very exactly like that. What we're going to see is how can AI help in consuming papers in a simpler way that we don't have to actually go and read all those papers, but just get the summary or gist of it and then decide whether we want to go into detail or not. So in the previous video, we looked into Google's one of the new papers called PaperBanana, which is really a good way to kind of make AI generate scientific paper diagrams that are used in papers, methodology diagrams, plots, and so on. But what we didn't do is we looked into the paper, but we didn't go in detail inside the paper. So today, what I want to do is it's more of a trial and error. I've not done this before. Is I'm not going to go and read the paper, but I'm going to pass this to AI in different forms of AI, and then I'm going to see how we can actually understand the paper or what is AI telling us about the paper that we can consume. Right. So let's jump in. So the first tool I'm going to try, which is to consume technical papers in a very simple way, is called Saral AI. As a disclaimer, I'm part of the team in Saral AI. What you could do is that you can turn academic papers into engaging videos, slides, and other formats, right? So let's try this right away. So first step is like you click on this Solidify, and then it allows you to kind of log in. So once you're logged in, this is the screen you'll get. It's usually a Google account that you could do for your login. And here you can either configure your own API keys from Gemini, or just for this demo, I'm just going to skip that and use the default keys that's provided by Saral AI. So by the way, Saral in different languages, Indian languages, means easy. So it's like something to make things easy, information easy, and so on. So what next is that in this screen, you can see that you could either upload a PDF or you can like upload the LaTeX source or the archive. So I had already downloaded the PDF of PaperBanana, so I'm just going to upload the PaperBanana's PDF. So the file is just getting uploaded. Click this file just upload. It's a large file, by the way. It's about 40, almost 41 megabytes. And so now it has different options. We can either do like process the PDF file. You could do like a full-fledged video and slides, but just for the make things quick, I'm just going to click on one-click video so that we just do this really fast, and you want to consume this information. That's the advantage of this over a few other similar methods. So you can see that there is quite a lot of time remaining here. So let's come back after it's done. So it's still going on. So I encourage everybody to try, take a PDF and maybe you can try converting it to video or generating a reel or a plot podcast or even a poster. Easy. So this tool, Saral AI, is both for people who'd like to kind of consume information in an easier way, but also for researchers who would like to maybe use these AI-based tools to make their presentations and other things better. So we're almost there. And the reason why I click on this is that it's first, it's fast, and also I would get a very quick summary of the paper in a short amount of time. I'm hoping this works. Not tried this before for this paper, so let's see. And especially given that this is it's a 41 megabyte paper. So one of the interesting things is that most paper most of the like other similar tools, they would ask for link or archive or PDF. Here you could also upload your LaTeX source, especially researchers who use LaTeX as their main. So instead of a one-click video, what I ended up doing is I ended up clicking on the one-click podcast. So let's listen to a podcast. It's only like 3 minutes 45 seconds, and let's see how this 3-minute 45-second podcast has compressed the whole paper and what kind of information it can give us. So let me play this, and let's also see the paper and other things simultaneously.
Hey Rohan, Ready to dive into this paper on automated academic illustrations?
Absolutely, Aisha. An AI that makes figures for research papers sounds wild.
Right? The title kind of undersells it, honestly. It's called Less Than Method Name Greater Than Dot.
Less than method name, greater than, catchy. So what's the big idea here?
Basically, it's an AI framework that can generate diagrams and plots for research papers automatically.
No way, like you feed text and it spits out a figure?
Exactly. They're trying to automate the visual communication of science.
Okay, I'm intrigued. What problem are they trying to solve?
Well, apparently, researchers spend a ton of time making figures. It's a bottleneck.
Makes sense. I've definitely spent hours tweaking a single graph.
And existing AI struggles with the visual aspect, especially for academic standards.
So code-based methods aren't expressive enough and image gen models aren't reliable?
That's the gist of it. They need something that combines both.
So how does less than method name greater than actually work? What's under the hood?
It's an agentic framework, meaning it uses multiple specialized AI agents.
Agent
The one funny thing is, I think it did not get the paper name right. I think it says less than, greater than, something like that. But basically, that would have been because of the icon or something when it tries to pause. So the paper banana is not getting that, but it's trying to get the other ones right. It was able to say that this is basically a method to kind of draw scientific illustrations using AI. So let's get back.
agents, like little AI helpers?
Precisely. They mention 5: retriever, planner, stylist, visualizer, and critic.
Okay, walk me through it. What does each one do?
First, the retriever finds relevant example figures.
Like, it searches for similar figures to use as inspiration?
Yeah, then the planner creates a detailed plan for the new figure.
And the stylist makes it look good, right? Consistent with academic norms?
Exactly. Then the visualizer actually generates the image.
And finally, the critic critiques it?
Yes, it refines the image iteratively. It's a whole
Yesterday we were looking into this, like the previous video, the iterative refinement, the 5 types of agentic orchestrations that are there, and so on. So it's nicely summarized when two people are talking about it as a podcast. Very similar to NotebookLM, but I think this is a little bit Indianized version.
collaborative process.
Wow, that's complex. What kind of inputs does it need?
A methodology description and a figure caption.
So, like, the text from the paper's method section and the figure's title?
Yeah, it uses those to create the visual representation.
And they tested it on methodology diagrams and statistical plots?
Exactly. They wanted to show it was versatile.
So, how did they evaluate it? Did they just look at the pictures?
They created a new benchmark called less than benchmark name greater than dot.
Less than benchmark name greater than what's that?
A data set of 200.
For some reason, it's not able to get paper banana. It's naming. I think it's renamed paper banana to like less than, greater than something.
192 real figures from newer IPS publications and corresponding text.
Smart. And how did they judge the generated figures?
They used another VLM as a judge, scoring them on faithfulness, conciseness, readability, and aesthetics.
A VLM judging
So just made it a little faster.
images? That's meta.
I know, right? And they correlated those scores with human judgments to make sure it was reliable.
And the results? Did less than method name greater than actually work?
It outperformed the baselines on all 4 evaluation metrics.
That's impressive. So, does this mean we'll have AI creating all our figures soon?
Maybe. They even used less than method name greater than to generate some figures in the paper itself.
Seriously? That's some serious dog fooding.
I know. They also explored enhancing existing figures and generating statistical plots. Exactly. A huge step towards automating.
It's just I think I was telling this in the previous video. Figures and this usually takes a long time, and you also need to be in the right mind frame to put that. And then it's like sometimes if you're not able to finish it, you want to do it maybe tomorrow, and then you'll be able to get stuck in a loop. So you want to avoid that as much as possible.
In the scientific process.
So, to recap, less than method name greater than automates academic illustrations using specialized AI agents.
Evaluated on a new benchmark, and it beats the competition.
Pretty cool stuff. Thanks for walking me through it, Aisha.
No problem, Rohan. It's exciting to see AI tackling these kinds of creative tasks.
Like you heard it, right? It's Rohan and Aisha speaking, and two AI voices. It's almost like they are just talking to each other, and then one person is explaining the paper to the other person. Pretty amazing how seamless it has been, and how Indianized also to an extent. So the Saral video is also done now, so let's go and see how that's come out. So after the processing the PDF, we get the the video for the PaperBanana from Saral AI. So it's only a 2 minute, 2 minute plus video. So that should give us a very quick gist of what the paper is about.
Presentation on PaperBanana, automating academic illustration for AI scientists. This research was conducted by Dave Zhu et al. And published in Feb 2026. Today, we'll explore the key findings and contributions of this important work. Let's begin by understanding the problem this research addresses. Autonomous scientific discovery is a long-standing pursuit of artificial general intelligence. With the rapid evolution of large language models, LLMs, autonomous AI scientists have demonstrated the potential to automate many facets of the research life cycle. Yet scientific discoveries achieve their full value only through effective communication. The methodology is presented as a task formulation and an agentic framework. The task formulation.
So what it's trying to say is that diagrams are very important. The last line must be skipped, but so it says that despite the proficiency in textual analysis and code execution, autonomous AI scientists struggle to visually communicate the discoveries, especially for generating illustrations, diagrams, and plots that adhere to rigorous standards of academic manuscripts. So basically, it's that yes, we can come out with really good like diagrams and illustrations, but that usually depends on the like the artistic nature or how the taste of the scientist or the researchers who are doing that. Some may have really good skills like artistic skills, and they may know how to like visually communicate and illustrate things in a nice way. But from my experience, majority of do not know that. Only a few take the time to actually communicate in a nice way. So if AI can play a role here and bridge the gap and help the majority of scientists to actually like communicate their work in a nice way through these diagrams and illustrations, that's going to be really great, right? So that's what I think we can draw from this introduction of what Cyril has come out with regards to the paper. So let me play more.
The methodology is presented as a task formulation and an agentic framework. The task formulation defines automated academic illustration generation as learning a mapping from a source context and a communicative intent to a visual representation, optionally augmented by reference examples. The agentic framework, illustrated in Figure 2, comprises 5 specialized agents: retriever, planner, stylist, visualizer, and critic. Comprehensive experiments on the benchmark demonstrate the effectiveness of our method. Our method consistently outperforms.
So one good thing is that we had a very high level gist of what he's doing, but again, this is just a 2 minute, 2.5 minute video, so it's not going into like extreme details. It just gives a very high level introduction, right? So that's one thing just thought of mentioning, and now it's moved from methodology to actual results.
Leading baselines across all 4 evaluation dimensions: faithfulness, conciseness, readability, and aesthetics. Specifically, our method with Nano Banana Pro achieves significant improvements over the vanilla Nano Banana Pro baseline in faithfulness 2.8, conciseness 37.2, readability 12.9, and Aesthetics 6.6. The discussion section explores intriguing settings and implications of our framework. One key area is the enhancement of aesthetics for human-drawn diagrams by leveraging the auto-summarized aesthetic guidelines. Our framework can suggest improvements to existing illustrations, refining their visual appeal in terms of color schemes, typography, and graphical elements. This was demonstrated.
So this is what I mentioned earlier, right? Like it's also great that this feature is there. As scientists, humans, we can come up maybe with an initial draft or an idea on our head, and I mean, you know that we can easily put these using some basic blocks or like PowerPoint and things like that. But if these could be even more aesthetically given better appeal, and if AI can actually help that, that's going to create a lot of change in how like scientific papers are communicated. Basically, you're going to raise the bar from here to here, and you're going to get really good outputs in these things.
To be effective, with refined diagrams showing stylistic improvements. This paper introduces an agentic framework designed to automate the generation of publication-ready academic illustrations. By orchestrating specialized agents, our approach transforms scientific content into high-fidelity methodology diagrams and statistical plots. To facilitate rigorous evaluation, a comprehensive benchmark curated from top-tier AI conferences was presented.
So I think that's mostly it from this. I think by design it was kept so that the timing is not too long. It's only like less than 3 minutes. So it just gives a really high level gist of the. So hey, by now we have some idea of what PaperBanana is about. So what you're going to do next is try to see you can understand the paper using some more tools like NotebookLM, which is an amazing tool for like podcasts, and then also it generates video summaries. So let's see that. So here is a podcast that was generated using NotebookLM, and this was shared by Satya Malik, the CEO of OpenCV. They do share these types of lots of podcasts from NotebookLM from time to time. So let's just jump right in and see what this is about, so I don't have to generate this same thing again.
Imagine spending 6 months on your groundbreaking research, only to waste a week fighting with software just to make a diagram that doesn't look like it. Well, a complete mess. Welcome to our podcast, Artificial Intelligence, Papers and Concepts, curated by Dr. Satya Malik. And just a quick heads up before we dive in, you're listening to a conversation between two AI-generated voices. We love
So that is too fast, so I'm just going to reduce the speed, maybe slightly less.
learning, but we don't actually have brains, bodies, or PhDs.
We just have the source material.
And today's topic, it has a name that sounds delicious. We're talking about PaperBanana.
Yes, PaperBanana. It is a bit of a whimsical name for a very rigorous solution.
I have to be honest, when I first saw the title, I thought maybe a smoothie recipe, a new item in Mario Kart. But this is a serious tool, isn't it?
Oh, very serious. It's what the researchers call an agentic framework.
Okay.
It was developed by researchers from Peking University and Google Cloud AI Research to tackle this huge bottleneck in the scientific workflow.
The bottleneck being that most scientists are brilliant at math and let's just say less brilliant at art.
Precisely. It's what they call the visualization gap. You've done the work, you've written the paper, but getting that complex idea into a clear, professional-looking diagram.
It's a nightmare. I mean, I've seen people use PowerPoint and things just never line up.
Right.
And then you have the really hardcore folks using something like Tixi.
Okay.
For those of you listening who value your sanity, Tixi is basically writing code just to draw circles and lines.
That's interesting. So I was just wondering what Tixi is. So I'm glad that the Notebook Banana podcast is not just bringing up something. I mean, of course, I'll go and verify it later, but it's actually telling what Tixi is, right? So that's very interesting to see.
It has a learning curve that is basically a vertical wall.
Yeah.
The whole promise of PaperBanana is to just bypass all of that. You feed it your text, the actual paragraphs from your paper.
And a caption, I see.
And a caption, yes.
Yeah.
And it acts like an autonomous art department. It just spits out a diagram that's ready for publication.
That is a big claim, though, because we've all played with image generators.
Right.
If I tell Midjourney to draw a flowchart, I get something that looks cool, but the text is gibberish, the lines don't connect properly. Is this just that?
No, and that's the key.
So that's really true, actually. So for a long time, these image generators they used to give out some cool images, but most of the times the text used to be like I've tried it myself. Text used to be really bad. Sometimes even not even the correct spellings, and so the lines and other curves also used to be pretty bad. So that's whatever it's telling is actually really factual. I've experienced it myself.
That's the critical difference here. A standard image generator is a one-shot model.
You prompt, it gives you a picture.
Exactly. It just kind of hallucinates a result. PaperBanana is an agentic framework.
Okay, let's pause on that word, agentic. We are hearing that a lot lately. What does that actually mean? Break that down for us.
Think of a standard AI like a really talented but impulsive artist. You shout an idea, they splash paint on a canvas.
Right, instant result.
Agentic system is more like running a whole design studio. You don't just have an artist. You have a manager, a researcher, a planner, even a critic. They all talk to each other.
So it's a team effort, not a solo performance.
Exactly. They break the job down into steps and they iterate.
That makes a lot of sense. And before we get to meet the staff of this digital design studio, we do need to pay our own bills.
Indeed.
This podcast is sponsored by BigVision.ai, a consulting and product development company that helps companies of all sizes build computer vision and AI solutions. You can reach them at contact@bigvision.ai.
Big Vision is doing some really great work in the field.
Okay, so back to the PaperBanana studio. Let's walk through this assembly line. I've got my
Well, that's a really interesting. I know like Satya was also running a consulting firm called Big Vision in computer vision and AI solutions. So I think the Notebook Banana must have been prompted, like given some system prompts instructions to say that, okay, it's not just a random Notebook LM podcast, but also feed this message in so that it feels like a something like a program, and then it says that, oh, this program is brought to you by so and so, right? So that's another interesting thing that just come by.
I hand it over. Who gets it first?
The first agent is the retriever agent. And this is interesting because it doesn't actually start drawing.
It doesn't.
No, it starts by looking for inspiration.
Inspiration? You mean like browsing Pinterest for diagrams?
Sort of, yeah. It searches a reference set in the paper. They used 292 examples from NeurIPS 2025 to find diagrams that are similar.
But similar how? Same topic.
That's the clever part, not the same topic. It's looking for similar structural logic and visual style.
Oh, I see. So if my method involves a feedback loop, it might pull up a diagram from a totally different field that also has a loop in it.
Precisely. It's looking for the vibe of the layout. Is it linear? Is it cyclical? This grounds the whole process in what a real professional diagram should look like.
That's smart. It's like bringing a mood board to a meeting. Make it look something like this. Okay, so
That's very interesting. I previously worked on a mood board related project, so I can totally relate to what it is. I never knew what a mood board was, but it's like how say designers, architects, and others, like they bring interior designers bring all these board and they put all of these things in, and then it kind of you iterate over it. So it's nice to know that it's PaperBanana is kind of relating this to that. And one interesting thing is that, which I'm wondering, is that so it says that, okay, this paper we've seen before, that it has a database of Europe's paper that it tries to kind of papers it tries to like get inspiration from and so on, right? But here's the question that I'm wondering, and I wonder if NotebookLM will actually be discussing this later on, is that, so it has taken Europe's 2025, I mean, the Europe's papers, 200 plus papers or whatever, but is there, so, and it's going to copy the styles from those authors, and then, or get inspired, if we don't say copy. But what about copyright? Is there some, by copying these things, is there going to be some copyright? Are these AI models being trained without even being like from the papers, other papers, Europe's papers, without we'll not be able to like go and get attribution for this. So there are some like niche points here. So let's see if the NotebookLM podcast actually discusses those. It'd be interesting to see if it does. So let's get back.
the retriever finds a reference. Who's next?
Next up is the planner agent. This is really the brain of the operation. It takes your raw text and the examples the retriever found, and it writes a detailed plan.
And what's in that plan? A sketch.
It's more like a script. It maps out the nodes, the connections, the whole flow. It's the bridge from just a block of text to an actual visual concept.
Okay, so we have a blueprint. But, a blueprint can still be made to look really ugly. I've seen scientific posters that use neon green on yellow. It still haunts me.
And that is exactly why the next agent is so important, the stylist agent.
The stylist, I like it.
The stylist handles all the aesthetics. The researchers actually had the system analyze hundreds of papers from top journals to extract what they call a comprehensive aesthetic guideline.
Wait, they basically reverse engineered good taste?
Essentially, yes. The
Yeah.
stylist enforces rules, typography, color harmony, layout balance, and make sure the final product looks like it belongs in nature or science.
I appreciate that. I mean, bad design can actually ruin good science. There's this bias where if the font is terrible, I just instinctively trust the math less.
It's a real cognitive bias. The halo effect. Good design implies competence.
So we've got
So here I wonder, like, so again, this is also even the style is going to be based on a database of papers, and then it's basically going to say how you could aesthetically modify the blueprint to a nice style. That's actually interesting. And I wonder the same thing, was there like copyright from the other stylists and designers who would have actually like spent a lot of time in doing that? So that is something which would be interesting to look at. So that's what I'm wondering.
plan and a style guide. Who actually draws the thing?
That would be the visualizer agent. This is the one that uses an image generation model. They tested a few, like NanoBanana Pro and GeoPT Image.
Okay.
It takes all the instructions from the planner and the stylist, and it renders the actual pixels.
But that brings me back to my first worry. Image generators, they mess up the details. I can't have a diagram in my paper that spells algorithm with a silent Q.
You are absolutely right. The visualizer is prone to making mistakes, which is why the final agent is probably the most important of all.
And that is
The critic agent.
the strict supervisor.
The critic creates that closed loop we talked about. It looks at the image the visualizer made, and it compares it right back to the original text.
Asking questions like, did we miss an arrow?
Is this label spelled correctly? Does this flow actually make sense based on the text? And if it finds an error,
It sends it back.
it sends it back with notes. Fix this. And they run this loop 3 times.
That iterative process, that try, critique, fix loop, that seems to be what separates these new systems. It feels more human.
Right.
We don't get things right on the first draft.
Exactly. It's a self-correcting mechanism. In science, close enough is never good enough. The critic is the firewall.
Okay, so the team is retriever, planner, stylist, visualizer, and critic. It sounds great on paper. Does it actually work?
The authors anticipated that question, so they've built a benchmark. They call it PaperBanana Bench.
Of course they did. I love the names they come up with.
It has 292 test cases from NeurPS 2025 papers, and they compared PaperBanana against, just a standard vanilla image generator.
And against humans, I hope.
And against the original human-created diagram.
Okay, and the verdict.
It's fascinating. I mean, it crushes the vanilla models, no surprise there. But against humans, the results are really nuanced.
Nuance is always code for it's complicated.
It is. So in terms of conciseness and aesthetics, PaperBanana actually scores higher than the humans.
Hold on. The AI makes better looking diagrams than the actual scientists who made them.
Significantly better, yes. For conciseness, it scored over 37% higher. It turns out that human researchers, well, we often add too much clutter. We try to cram everything in one box.
Or we just use terrible colors.
Or terrible colors. The AI is a filter for all those bad design habits. It simplifies things.
That feels like a bit of a roast of the entire academic community, but I'll allow it. So it's basically the Marie Kondo of diagrams.
That's a great way to put it. But you asked about the nuance.
Yeah, where is it?
It's reversing the way in which it puts says how AI is actually like making diagrams even better than the scientists who had originally like created them. That's really nice. I have no idea who Marie Kondo is, but that's something for me to look up.
It falls short, let me guess. Faithfulness. Is it actually accurate?
You got it. While the diagrams are pretty and clean, it still struggles with faithfulness, with accuracy compared to humans.
The pretty but wrong problem.
Exactly. It might generate this stunning diagram, but maybe one arrow is pointing the wrong way.
Which, in science, is not a small...
So what is faithfulness? Is it saying accuracy or hallucination? From the context, it looks that way, but I wonder why they named it faithfulness, and instead of just calling it how accurate the diagram is, or how what is the hallucination?
Mistake. That's a disaster. If input A goes to process B and the AI draws it going to process C, that's misinformation.
It's fundamental misinformation. The paper's failure analysis shows these specific cases. The AI drew a connection that looked visually plausible, but it just wasn't in the method. Or it mismatched nodes.
Wasn't the critic agent supposed to catch that?
It catches a lot of them, but not all of them. Visual reasoning is incredibly hard. The critic can see there is an arrow, but it might not understand that the arrowhead being on the wrong end changes the entire meaning.
That's a dangerous trap then. If a diagram looks really professional, my brain is kind of tricked into trusting it more.
That is the biggest risk, because it's so good you might get lazy. The authors are very clear. Human oversight is mandatory. You have to audit every single connection.
So here's the interesting part. So I don't know how, I'm not just seen the code yet, but what would be really great, I've done this myself, what would be really good if it actually not just produces a diagram, but actually gives you a way to edit these diagrams. So in that way, like if it generates, say, a wrong arrow, like what they've been pointing here, we can go and just change the arrow, right? If it's just going to give you like something like just a PNG or JPG, that's not easily possible.
Job shifts from being the artist to being the editor-in-chief.
Exactly. Now there's another part to this. It's not just flowcharts. Papers are full of data plots, bar charts, line graphs.
How does it handle those? That seems even harder.
It is, and this is where the approach gets really clever. They realized they couldn't just use the image generator for data. Well, think about it. If you ask an image model to draw a bar chart showing a value of 0.6, it'll draw a bar. But if you actually measure the pixels, that bar might be at 0.9 or 0.4.
Right. It creates the idea of the data, not the actual data. It just hallucinates the numbers.
It's terrible at math. So for statistical plots, the visualizer agent switches its strategy. It doesn't generate pixels.
What does it do?
It writes Python code.
No way. It writes a matplotlib script.
Exactly. It takes your description and writes the code to generate that plot. That ensures numerical precision.
That is very interesting. So that's nice to know. I think maybe I've seen it in the previous versions as we were trying to understand the paper. So what they're saying is that to draw these experimental plots, instead of generating the plots, you generate the matplotlib script, and that's going to be more accurate so that you don't miss out on the hallucinations or the wrong things. So the script should be, and we've seen before that AI is very good at writing code as opposed to like generating diagrams. So this could maybe hit that. And I would not be surprised if the accuracy rate for this is much better than the previous one, the methodology one.
The bar is at exactly 0.6 because the code literally says why 0.6.
That is so smart. So for the conceptual stuff, it paints, but for the hard data, it programs.
And they even suggest a hybrid approach. For a simple, sparse plot, the image generator might look better. But for complex, dense data, you have to use code to be accurate.
It's amazing. The system has enough self-awareness to know when it shouldn't be trusted, to say, I should calculate this, not just draw it.
That's a vital distinction.
But I want to talk about my favorite feature from the paper, the makeover capability.
Yes, the remediation feature.
This is for every researcher who's ever made a diagram that looks like it was drawn on a napkin. after 3 cups of coffee.
Or in MS Paint back in 1998.
Yes.
You can feed PaperBanana your own ugly diagram.
Yeah.
The stylus agent analyzes it, keeps all the logic the same, but redesigns it completely to meet professional standards.
It's like Queer Eye for your research paper.
That's really amazing. So maybe I missed this in the previous or maybe it's not there. So you could just draw a rough diagram and feed it in, and it's going to make a better version, a nicer version of that. So that's really nice.
It is, and in their tests, the enhanced diagrams won against the originals over 56% of the time. It just fixes everything: the fonts, the colors, the alignment.
I think that might be the most immediate use case for so many people.
Oh,
I would use that today.
I think we all would.
But let's look at the downsides again. We talked about faithfulness. What else is holding this back from being perfect?
There's a big technical limitation. It might sound a bit dry, but for a scientist, it can be a deal breaker. It's raster versus vector.
Okay, break that down. Raster is pixels, like a JPEG. Vector is math, like an SVG.
You've got it. PaperBanana currently outputs raster images, pixels. But scientists almost always need vector files.
Why is that so important?
Too big.
Yeah, so I was just saying, like, unless we were able to edit these, it's not going to be that helpful unless it just gets it right in the first few times.
Reasons. First, printing. A raster image gets blurry when you zoom in. A vector stays perfectly crisp. But second, and this is the big one, editability.
Oh, of course.
Yep, they got it. This is exactly what I was talking about. Editability.
It's 2 days before the deadline, and your advisor says, can you just move that one box a little bit to the left?
Exactly. With a raster image, you can't. That box isn't an object. It's just a bunch of colored pixels. You have to go back and regenerate the whole thing.
I hope the AI draws it the same way again. You lose all that fine-grained control.
That's the problem. The authors know this, though. They suggest a future version could have agents that directly control software like Adobe Illustrator.
That would be something else. An AI literally moving the mouse in Illustrator for you.
It feels like the next frontier, moving from generating pixels to actually operating tools.
So if we step back, PaperBanana is amazing. It beats us on aesthetics, it speeds things up, but it has this faithfulness risk and the vector limitation.
Right.
It's not quite ready to take over the lab.
No, not yet. It does represent a huge shift. We're moving away from just prompting a model and hoping for the best.
Right.
We're moving towards managing a team of AI agents that can plan and critique and execute a complex task.
It really changes our role from creator to, I don't know, manager, editor-in-chief.
That's a good way to put it. You set the direction, you review the final work, but you don't push the pixels yourself.
You know, thinking about this, there's a deeper implication here. Right now, the AI reads your paper and it draws a diagram of your method.
Yes.
But remember that critic agent, the one that looks for logical inconsistencies in the drawing.
I see where you're going with this.
If the AI gets good enough to understand the logic of your method, how long until it reads your paper, tries to draw the diagram, and then just stops and says, hey, wait a minute, I can't draw this because your method itself has a logical flaw?
That is a profound thought. How long until the AI is not just visualizing your work, actively finding the holes in your theory before you do?
Exactly.
That is absolutely amazing. It's amazing. I don't know if this is actually there in the paper. This is why one of the reasons why I really like NotebookLM is because I think I've seen it so many podcasts, similar ones. Towards the end, they make you curious and they make you think. It adds something something is inspiring, and maybe it's there in their system to obligate. Maybe ask these questions towards the end. So that I wonder if it can. So going back to this paper, so they're asking, like, what if it does not just draw diagrams, but it can even suggest better ways of suggesting flaws in your thinking, or saying that maybe this is a better way to illustrate, right? So that's really interesting.
Sorry, Dave, I can't draw that diagram. Your math doesn't add up.
That's the moment it stops being an illustrator and starts being a collaborator, or maybe even a peer reviewer. And honestly, that might be closer than we think.
On that slightly terrifying but also exciting note, we will wrap up this deep dive into PaperBanana.
It's been a pleasure.
A huge thank you to our listeners for tuning in. If you want to see if our future deep dives are written by us or an agentic framework, please subscribe to our show so you don't miss the next one. We'll see you then.
Alrighty, that's the end. So I really liked it. It's 14 minutes, but it ended my process a few more, but that's pretty nice. Hey, so far we've seen the podcast, we've seen like a quick summary of the paper. So last one, in order to distill the paper, to understand the paper, what you're going to see is a NotebookLM video. So NotebookLM also generates a video. So let's see how that happens. Again, remember that we've not even gone inside the paper. So we're just using AI tools to understand the paper. So let's see what happens.
Today, we're diving into an AI that's tackling one of the biggest and maybe most unspoken challenges in science. It's not just making a discovery, it's about explaining it. So let me just ask you a question. When you think about what a scientist does all day, what do you figure is the biggest strain on their time? Is it running the experiments, crunching the data? You might actually be surprised by the answer. For a lot of researchers, the real grind, the real hard part, comes after the big aha moment. It's communicating that discovery to the rest of the world. And a huge piece of that puzzle is creating these incredibly dense visual explanations of really complex systems. These aren't just simple pictures, they're like visual essays, and they can take days, sometimes even weeks of painstaking manual work to get just right. And this all leads us to what the researchers behind today's topic call science's big bottleneck. Think about it. We've got AI models getting incredibly good at speeding up the actual research and analysis. But that very last step, creating the publication-ready illustrations, is still, for the most part, a manual, kind of painful process. And this friction, this bottleneck, well, it slows down how fast new ideas can be shared, reviewed, and then built upon by other scientists. But what if an AI could not only help do the science, but also draw the pictures? Well, that's where our story really gets interesting. So
That's really interesting. So the way in which it motivates, the video motivates this, right? And then it gives a what if scenario. So I heard that what if scenarios are a great way to motivate and captivate an audience. It's really nice. Only thing I'm not sure is, as far as I know, the paper only does the drawing, not the science, but it's trying to see if it can do, if it's trying to motivate us, if it can do both. Let's see whether it says only the drawing part.
let's meet the potential solution, PaperBanana. Okay, so what is PaperBanana? It's a brand new system developed by a joint team from Google and Peking University. And I want to be clear, this is not just another image generator. The creators call it an agentic framework. That sounds pretty technical, right? But it's really just a fancy way of saying it's a team of AIs working together on one very specific and very difficult job: to automatically create the kind of top-notch illustrations you'd find in a serious scientific journal. So the whole point here is this. PaperBanana's mission is to read the dense technical text of a research paper and translate it into a clear, accurate, and professional-looking visual. It's kind of like an AI artist that also happens to have a PhD in science. But how does it actually pull this off? Well, it's not just one single AI doing all the work. The real magic of PaperBanana is that it's designed to be an AI dream team, where every single member has its own very specific role to play. And this right here is the blueprint. See, PaperBanana isn't some black box AI. It's a really carefully structured workflow, a team of 5 distinct AI agents all collaborating to get the job done. You can almost think of it as an assembly line for scientific art. To make sense of it, we can really break this whole process down into 2 main stages. First up, there's the planning phase. That's where all the prep work gets done. And then second, you have the refinement loop, which is where the illustration is actually created and perfected. So in that first planning phase, you've got 3 agents working one after another. It all starts with the retriever, which acts like a librarian. It searches through a big database to find existing diagrams it can use for inspiration. Next, the planner steps in. It's like an architect, taking the scientist's text and those examples and drawing up a super detailed blueprint for the new image. And finally, the stylist, who's basically the graphic designer, makes sure that plan follows all the strict aesthetic rules of academic papers.
So I really like the illustration here, how it, we've seen this before, but if you see here, it's like it tries to visually also illustrate, right? There's a retriever, which is going to be more like a computer, and then a planner, like they put like an architect slash, with, you can see the hat, construction worker kind of thing. And then you have the stylist, which is also, it's like you have AI, but it also kind of adds a little bit of artistic layer to that. So again, when we see images like these, it's a nice way to kind of understand, and it'll help us to like map, do the mapping, visual mapping.
Things like color schemes and fonts. Okay, once that detailed plan is locked in, the second phase kicks off. And this is where the real teamwork happens. It's a cycle of creation and critique, all designed to polish that final product until it shines. In this loop, we meet our last 2 agents. The visualizer is the artist of the group. It takes
So this is what I remember. It's very similar to generative adversarial networks, or GANs. You have the loop, which does the generation and then discrimination.
the plan and generates the first draft of the image. But it doesn't stop there. The critic, who acts like a sharp-eyed editor, immediately inspects that image. It's checking for any mistakes, awkward layouts, or anything at all that doesn't quite match the original science. It then gives feedback to the visualizer, and the artist tries again. This whole process, this loop, runs 3 times. And with each cycle, the illustration just gets better and better. So it sounds like a brilliant system in theory, right? But here's the billion-dollar question. Actually work? And how in the world do you even grade an AI on its artistic and scientific skills? To find out, the researchers actually built their own final exam for it, and they called it PaperBanana Bench. What they did was collect 292 complex diagrams from a top AI conference to use as a gold standard. So this wasn't some easy multiple choice test. PaperBanana had to create visuals that could stand shoulder to shoulder with illustrations made by some of the top human researchers in the world.
There's a very small point here. So it kind of did not pronounce NeurIPS 2025, but I said the top AI conference, because as an AI, sometimes pronouncing these could be difficult. So that's a very clever way. I don't know how it was prompted, but that's a nice way of doing it.
And the results, they were pretty darn impressive. In one of the key areas, conciseness, which is basically how clearly and efficiently the diagram gets its point across, PaperBanana outperformed other leading AI systems by a massive 37.2%. It also showed a nearly 13% improvement in readability. That just means the text, the labels, and the overall flow of the diagrams it created were significantly easier for a person to understand.
So another minor point here, right? If I were a human, I would not want to say 12.9%, but it says almost 13%. So that's also really a minor point, but that's really nice to appreciate that.
So it wasn't just making pretty pictures, it was making functional, effective tools for science. But the performance wasn't just about scoring high on these specific metrics. What the researchers found was that this whole agent-based system was just incredibly versatile. It was definitely not a one-trick pony. It could generate a huge variety of visuals. For instance, it could produce these complex statistical plots, bar charts and line graphs that are just jam-packed with data, but still have to be super clean and easy to interpret. And on the other end of the spectrum, it could create these really intricate methodology diagrams. In fact, you see the diagram on the right, the one that's actually explaining the PaperBanana framework itself, that was generated by PaperBanana. It's an AI that is literally smart enough to draw its own family portrait. So what does all of this mean for the future? Well, by solving this illustration problem, we're getting one step closer to a much bigger, much more fascinating idea, the fully automated scientist. As the researchers themselves put it, this work paves the way for the automated generation of publication-ready illustrations. They really see this as a foundational step towards something much bigger. And that, right there, is the ultimate takeaway. This isn't just about saving scientists a bit of time and frustration. By automating one of the slowest, most labor-intensive parts of the scientific process, tools like PaperBanana have the potential to speed up the entire cycle, from that initial discovery to communication to the next big breakthrough. And it really leaves us with a pretty profound question to chew on. If an AI can handle the hard work of explaining a discovery, that frees up our brightest human minds to focus on making the next one. So when AI truly masters the language of science, both in text and in visuals, what new frontiers is it going to help us find?
Wow, amazing. So we've seen so far how we used AI tools to pick a paper and try to understand what the paper is about, both in terms of small, quick summaries. That's where we used Saral AI, and then a little bit longer summaries, wherein we used like NotebookLM to kind of decode the paper. So I've still not read the paper, by the way. And there are, of course, more tools to kind of go and read the paper and then try to understand it better. But the idea is that how can we quickly grasp a paper and understand it to a reasonable extent, and then if we can decide whether we want to go and take a look at it in more detail or not, and how AI tools are helping in this. So that is one of the things that I'm just trying to do here. And I think like this has been a good enough exploration for me. So what I plan to do is that I'm going to maybe read more papers like this. Something we can say that AI, understanding papers with AI or something like that, right? And the workflow would be that first the quick summaries and then a little bit longer, and then decide whether I want to go or not. So in this case, we just took the PaperBanana paper and hopefully take more papers to come. And one more thing I just realized is that I think when I started this, the PaperBanana code was not out, but in the one of the few days I recently saw that they've also released the code. So in one more video, maybe the next in this PaperBanana series, hope to actually try the code for myself and also try to do a recording of that and see how things go. All right, until next time.